Okay, and welcome back to this fourth video on my series on anti-differentiation. And in this video, I'm going to talk about the special case of, it's kind of a polynomial, but it has a linear term on the inside, not just x. So we're not talking about x to the power of n, we're talking about ax plus b to the power of n. And this gives me a good opportunity to talk about how this is the end of the scope, the end of the line for this type of question. Because if we derive this thing, you would have a chain rule question. The n would come out the front, decrease to n minus 1, but you would end up multiplying by the derivative of ax plus b, which is all good. If we had inside that bracket something that wasn't linear, so this is just a linear function ax plus b, if it was, say, x squared plus 1, when you derive that, you would actually get 2x as your multiplier outside the front. And then all of a sudden, when you start integrating, there needs to be a 2x there. There's bigger problems. So when we're dealing with integrating polynomials, they either have to be in the form x to the power of n or ax plus b to the power of n, or they are considerably harder. Sometimes still possible, sometimes not possible. So we'll deal with some of those later on in this video series, but for now we're dealing with just a simple case where it's a linear function inside a bracket with a power rather than just x. So we know that the integral of x to the power of n, in this line here, dx is equal to x to the power of n plus 1 over n plus 1 plus c. So we know that we increase the power by 1, we divide by the new power. So what changes when x to the power of n goes to some linear to the power of n? And let's have a look at what changes in the differentiation. This is part of exploring, and so it's a really good approach to these types of problems. So the derivative of x to the power of n is nx to the power of n minus 1, whereas the derivative of ax plus b to the power of n is n times ax plus b to the power of n minus 1 times by the derivative of the inside function, so this is my shortcut chain rule, and that's a, times by a. Now technically you do the chain rule above as well. You do n down x to the power of n, and then you multiply by the derivative of x, but the derivative of x is 1. In this case, so we get an a. So when we derive ax plus b to the power of n, we get an additional factor of a, which means that when we integrate ax plus b to the power of n, we get ax plus b to the power of n plus 1 over n plus 1, but we have to divide by an additional factor of a, so that when we derive this to get back to the original function, it cancels out the extra factor of a that we'll get. So you need to go through, and really a good student, somebody who wants to be successful in the questions that vary slightly, will have a good understanding of why that's the case, and will build that understanding, ask questions and all that kind of thing. But for now, here's a rule, and for some of you that might be a good place to start as well. And of course we have a plus c, which I notoriously forget to add on, so I'm happy I've remembered in this case. So let's have a look at some examples, and I'll show you this procedure. So a, the integral of 2x plus 1 to the power of 6. So if we're integrating this, the answer will be 2x plus 1 to the power of 6 plus 1, which is 7, divided by 6 plus 1, but we also have to divide by 2. So we're going to divide by 2 and 6 plus 1, which means we can just divide by 2 times 6 plus 1 as I've written. And I'm going to do it like this, then I'm going to simplify. So I get 2x plus 1 to the power of 7, and I get 1 over 6 plus 1 is 7, 2 times 7 is 14. So it's 1/14 of that. Apologise, it's going a bit funny here. 1/14 plus c. Okay, there's me trying to stick to an appropriate set of lines. Okay, now I'm going to do this one here. This is a rational function, but I get, this becomes the integral of 2x plus 1 to the power of a half with respect to x. And now I can do this, and I'm going to actually create space and work down just to show you appropriate working, because we should work down our page rather than sideways. So this becomes 2x plus 1 to the power of 3 over 2, I've increased it by 1, divided by 2 times 3 over 2. plus c, and we can write that down as, sorry, that's incorrect. The 2 and the 2 cancel out there, which leaves 1/3 of 2x plus 1 to the power of 3 over 2 plus c. And of course, we could now write that back as a square root in its square root form if we wanted to. And this last one has a negative power, and so we have the integral of 1 over, which is, I'm trying to remove, 2x plus 1 to the power of negative 6 dx with respect to x, and that's equal to 2x plus 1 to the power of negative 5. I've increased by 1, divided by 2 times negative 5, the new power, and plus c. And so this, of course, is equal to negative 1/10 2x plus 1 to the power of negative 5 plus c, or, and they're both right, negative 1 over 10 times 2x plus 1 to the power of 5. So just take out that negative power and put it in the bottom of the fraction there as the other alternative writing. And of course, usually it's a good idea to go back to the form that you've been given the question in, but really at this stage of the game, it's probably not going to matter. So there we have our set of examples and methodology behind integrating any polynomial function using the polynomial laws. All the best.